My name is Brandon, and this is my physics lab 4, which is about oscillations. For this experiment, we were tasked with using Tracker to track the movement of an oscillating weight which is attached to a string, and this is in a video that was already given to us. After using Tracker to get the data, we were told to create a computational model of a scenario where a weight attached to a spring oscillates according to the correct forces. And the purpose of doing all this is so we can look into the principles of physics, which includes Newton's second law, the gravitational and spring forces, gravitational and spring potential energies, and kinetic energy. Here's a preview of the results, with the left being a graph of the change in energy over time, and the right showing the X and Y positions comparing both the video data and the computational data from the GlowScript code. The system is the object that you're observing, so in this scenario that is the weight, whereas the surroundings are everything else, which include the earth and the spring in this case. In the code for this lab, we use the velocity update formula, which is derived from Newton's second law. We also use the position update formula, which is seen here on the screen. In this scenario, the two forces at play are the force of gravity, seen on the left, and the spring force, which is seen on the right. And the total force is the combination of these two forces. This is called F net. Throughout this video, the three energies that are seen are kinetic energy, gravitational potential energy, and spring potential energy. And the total energy is these three added together. Here is the video that we were given to analyze. Now I'll be going through my computational model I made using GlowScript. Here are the initial conditions of the computational model, with the top showing the ball's mass, initial position, and initial velocity. At the bottom part of the screen, some crucial values are defined, including the spring constant, relaxed length of the spring, and other values used to define the spring force and the spring potential energy. Also, at the very bottom of the screen shows the individual energies and the total energy of this scenario. Now, in the calculation loop of the computational model, it defines the force of gravity, force of the spring, and the net force. And then this is used in both the velocity update and position update formula. Also, the change in energy is defined on the right side of the screen. This change in energy is shown on the left side, with the total energy change being 0, which is seen as the orange line constant across, and then the separate energies are what you can see oscillating up and down. And then on the right side of the screen, you can see the way that the spring and the weight moved as they oscillated. Here are both the X position and Y position of the weight as it moved throughout both the computational model and in the video, which, as you can see, are both very similar, however slightly different. These differences between the computational model and the video data can be explained for a few reasons, with one being small coding errors. While it didn't mess up the entire code, I could have messed up something very minor. And then also imprecision using Tracker is a big one, as I obviously can't perfectly put the tracking right in the middle of the weight for every single point as it goes throughout the video. And then also the initial conditions on the GlowScript are slightly off, which this causes the biggest bit of the difference, because when I put what the actual initial conditions were, it wouldn't actually go through it correctly. So these are the closest I could get to where they're still similar. An additional question for this lab is, for this model system, is the energy principle satisfied? And yes, the energy principle is satisfied, because in this plot of change in energy, you can see that the orange line is constant at 0, which means the total change in energy is 0. Another question is, using the data from Tracker, make two separate estimates of the oscillation periods for X and Y, And then using these numbers, I was able to do some subtractions with the x getting 1.6 and the y being 1.55, which these are slightly different. However, they're not the exact same due to imprecision in tracker. Thank you for listening to this lab.